we are gathered here at the Gariep Forever Resort at the 59th Grassland Society Congress. And we are talking to several speakers, keynote speakers, and listening to very interesting topics. Today you're a professor in the botany department at the Rhodes University, and yes, we're talking about forests today.
Yes, fire in the Kalahari nogal.
Yes.
Not really a place one associates with fire ecology, because unlike the wetter savannas where fire is essential to keep the vegetation open and grassy, and without fire it would turn into some kind of dense bush or even forest.
Yes.
The arid savannas generally don't need fire to stay open, and they also don't usually have that much fire. So fire ecology in those arid savannas has been much less developed than in the mesic savannas. But what you find happens in places like the Kalahari, even in really dry places, is if you have a couple of really wet summers, the grass gets really tall and it builds up, and then you have these hot days and often strong winds and thunderstorms, and you actually have got a really high risk of big runaway fires. So there have recently been 2 record rainfall summers, and in the last few years there have been a lot of big fires. And so we've started working at Tswalu Kalahari Reserve, which is a private game reserve, and they are concerned what the fires will do to the grass, whether after the fire it will recover to be forage for the animals, but also what it will do to the populations of the trees. Like there's the camel thorn, which is really iconic and hosts the big sociable weaver nests and stuff. But there's also Acacia mellifera or swartak, which is a notorious encroacher. And what happens if you have a couple of wet years is not only a high chance of fire, but there's also a high chance that the trees are going to make lots and lots of babies.
Yes.
And so it's been shown in previous studies that if you have 2 really wet summers, you have a great risk of a big recruitment event of especially that swartak. So we've been monitoring individual trees in plots. We have literally tagged and recorded 1,200 of them down to their tiniest babies to follow their fate since June 2022. And so we've resampled them twice to see how many seedlings are there, and there's hundreds per hectare, and how many of them actually survive and make it. And then we've experimentally burnt some of those plots to see what the response is to fire. And this is a long-term project that will keep going for the foreseeable future, where every year we resample these plots and study these trees to see how variation in rainfall affects whether these populations decline or whether they expand. And that's got really important consequences, because the Kalahari, like everywhere else, is experiencing climate change, and it's in fact a climate change hotspot. It's going to get much hotter. There'll be a lot more high fire index days in future, and rainfall events are predicted to be more extreme, and that might really change the game. And it's going to be very important for determining what the woody structure and the ecosystem services are of the Kalahari in the future.
So can we actually expect more fires in the Kalahari in the near future?
That is something we also plan to model based on past data, remote sensing data of fire extent, and relating it to temperature and moisture and all of those things. And then we plan to link that to climate modeled predictions to see if in the past this is how fires and the vegetation have responded to past rainfall variation. And if this is what we're predicting for the future, we can model different scenarios, we can get a better sense of what we might expect in the future. But I think fire certainly will be on the menu, and people do need to be ready for them and know what's in store.
And if I can ask you one last thing, what would you like the delegates to take home with them from this conference?
From this conference, just the really important bringing together of ecology and management with all its human dimension. We can do the most amazing ecological research, but if we don't translate it into action, it's not going to help anybody. So we do need to understand how ecology translates into management, which is very complex because there's economic constraints, there's tradition, there's all sorts of reasons why managers don't immediately pick up on the science you present. So I think that is a huge role for this society and for this meeting, is to bring together really good ecology, but also people really interested in how to translate it into management.
I first came to Africa to study rangelands and farms, and game farms in Namibia and Zambia about 20 years ago, and have since come back and lectured at the University of KwaZulu-Natal in grassland science, where Professor Kirkman I worked with has invited me back to give a talk here at the Grassland Society of Southern Africa here in the Free State. My research has focused lately on how we can use prescribed fire to benefit livestock production. In the states where we have prescribed fire or controlled burning, a lot of it's been focused on wildlife management and conservation areas. And when we've introduced grazing into burned areas, it's been mostly for the conservation benefits of that grazing disturbance. And we haven't really talked a lot in the States about how prescribed fire can directly benefit livestock production. And so that's been the focus of my research, first at a university when I was an academic in North Dakota State University in Fargo, which is even colder than here in the Free State. And now I'm at Eastern Montana, working for the government, doing research specifically on how we can use prescribed burning, but then also use areas that have burned in a wildfire as grazing opportunities, rather than needing to be overly protective of those areas and defer grazing or keep livestock off them in subsequent seasons. What we have found, some of my grad students working in North Dakota when I was at the university, is that we see much higher forage nutritive value in areas that have been burned, higher crude protein, higher net energy, lower lignin, lower fiber. So just a combination of all those factors shows that fire throughout the season, with multiple sampling periods throughout our grazing season, we consistently have the best forage quality in those burned patches. And we've also seen higher forage mineral content out there, which not high enough that no one would need to go and would have to stop supplementing their cattle or sheep with lick or nutrient mineral supplements, but we definitely see a reduction in the consumption of lick in areas that have been burned. So putting all that together, we see that cattle gain far more weight off of the burned pastures than continuously grazed without fire, even rotationally grazed pastures. And we also see a lot of effects in the soil, soil nitrogen, plant available nitrogen, ammonium and nitrate a lot higher in the burned areas, which probably explains why we're able to see the enhanced forage production and the enhanced nutritive value even late in the season. Months after there's been rain, we see higher crude protein in those burned areas, and that's probably because the benefits that we have to the soil microorganisms and plant available nitrogen for that grass to uptake. And so when in an area with a lot of rangeland and a lot of natural and human ignitions, we are interested in whether areas that have burned in a wildfire then have the same potential benefits as prescribed fire. Now, there's some concern about a wildfire being potentially higher severity and maybe damaging soils or grasses more than prescribed fire might. But what we're finding so far, myself and colleagues in our region, is that in grassland, when your fuel is dominated by grasses, fires move so fast that even a very intense fire under dry conditions moves so quickly that the heating into the soil isn't substantial enough to have a difference that's an effect that's much different than prescribed burning would be. So we're certainly seeing that wildfire areas, while they probably should be managed on a case-by-case basis, are definitely opportunities for grazing, and we don't necessarily need to avoid them. And so for South Africans thinking about this, there's a lot of fire in South Africa, and people intentionally burn, but there are controlled burns and there are wildfires. And then thinking about the difference between a prescribed fire where you've made a plan and are burning under certain weather conditions and have equipment and drip torches, versus some areas where burns are intentional but not necessarily planned or controlled. There might be some hesitancy to see grazing in areas where the fire hasn't been as well controlled, whether that's something coming out of the mountains or in a nature preserve, or something coming out of a communal area, if there's fuels to carry that fire. I think that one probably doesn't need to discriminate between fire types as long as it's moved through the grass layer and hasn't had substantial woody plant consumption. It's probably okay to graze, regardless of whether that fire was planned or whatever. And seasonality is also probably less of an issue because, again, soil is a really good insulator, and even what we think is a hot fire probably doesn't have that deleterious effect to soil and soil microorganisms and plant culms and buds, even when it's happening late in the dry season. South Africa is interesting because of the mix of native herbivores. So thinking of fire and the management of like game farms and all that, the different species of game and what they need to eat. And I think there's a lot of opportunity for these same sort of things to enhance game farming as well.
Wataru Takura is a student at UCT, and he is actually from a little town near Tokyo, and he's going to tell us a little bit more about what he was talking about at the conference, and it has something to do with the Nama Karoo, if I've got it right.
Thank you. I started my PhD last year in April to look at the vegetation condition in Karoo. And to do that, I'm using remote sensing technique to measure the bare ground in the field. To my surprise, Karoo is quite huge and large area, which covers 20% of South Africa and also like 30% equivalent to Japan land. So to measure the condition of the field, we need to use a kind of new approach using new technology. So I have decided to use a satellite data set to look at the condition. And I'm doing a bit complicated analysis using different predictors, kind of things in cloud computing environment. And so far, my prediction looks okay. And about the error is plus minus 50% in measuring bare ground in entire Karoo.
And what does that mean, Wataru?
What that means, so it's better than the other type of product which has been produced before. So that the arid area has been very challenging place for remote sensing analysis, because a lot of study has been done in Europe and North America. They are actually picking up greenness of the land to predict the vegetation. But Karoo is, it's green, but it's not a sort of greenness in Europe. So that we need to have a suitable predictor which is relevant for the land in South Africa. So my study is try to find the better or more relevant indicator to measure the condition of the land for the Karoo.
Wataru, thank you so much for your time today. And that was a PhD student from UCT.
My study is focusing on using remote sensing satellite products to estimate the water use of invasive alien trees in the grasslands of South Africa. So why this study is important is because we know through various studies that's been done in the past that woody invasive alien plants in particular can consume significant quantities of water from the landscape. And I think in South Africa that's really important because we are an already water scarce country. So the management of our water resources is extremely essential. So we really do have to make that effort and research of better understanding and quantifying how much water is being consumed by these woody invasives. So yeah, essentially what my research showed is that there are certain remote sensing products that work well in a South African landscape to estimate the water use of invasive aliens. The product that seemed to perform the best that we tested was called Vapor or Vapor. I'm not sure how you pronounce it. But yeah, it's essentially an African product. They've put a lot of special emphasis into the data set for Africa outside of other nations across the country, across the world. And what we find is that it works really well in South Africa. And so when we apply this remote sensing product, we find that there's actually a considerable difference in the water use of woody aliens compared to, let's say, an indigenous grassland. So I think this information is very important for policy, for the public sector. But I think outside of that, for agricultural and forestry and even conservation sectors as well. So yeah, it's quite exciting. There's still a lot to unpack into our estimations, refine the estimations of water use impacts of aliens. But there's just so much potential in remote sensing. It's becoming more integrative, and it is becoming more and more fine resolution as well, and just more user-friendly as well. So I think to an extent that looking into the future, that these remote sensing tools are going to become easier to use, and it will become more widely used as well, to essentially paint this picture of the impacts of invasive alien plants. Not only where they are across the landscape, but their impacts as well, taking it a step further and looking at their impacts. And so you can imagine as a management planner or as a policy maker or even just as a practitioner, you can use these tools to paint a picture of where the hotspots of impacts are, or what would be the best strategy to mitigate these impacts be. One can look at our integrated pest management approaches. So where does one use biocontrol, chemical control? Do we use an integrated approach and so forth? So answering these sort of questions is very important. And I think remote sensing doesn't solve all of those answers. It's not a silver bullet, but it certainly paints a picture for us.
Some of the forgotten concepts around grazing management, defining grazing management and understanding grazing management. So the topic of my talk was to look at stocking intensity and to use stocking intensity as a descriptor of rotational grazing systems. Currently, in popular media and scientific media, there's a lot of hype around high-density grazing systems and ultra-high-density grazing systems, and in particular, using the term density to describe grazing systems. But if you look at it from a scientific point of view and look at it analytically, the term density is relatively meaningless in a grazing system. Density would be defined as the number of animals per unit area at a point in time. It doesn't say anything about how long those animals are in that area, and therefore it doesn't say anything about how much forage is available to the animals while they are on that area. And so as such, it becomes quite confusing to farmers. So farmers may be prompted to stock their animals at a high density on a small area, but they don't really know what they're doing, why they're doing it, and what the implications are for animal performance. So stocking intensity can be defined as the number of animals or animal units for a particular period of time, and we can call that grazing days, on a particular area, which would be hectares. So animal unit grazing days per hectare, whereas density is just animal units per hectare. So that grazing days or the time actually comes into it, and that helps a lot to understanding grazing systems, in particular time-controlled grazing systems. So you can use that concept of stocking intensity to calculate the amount of forage you have available for your animals. You can calculate the amount of offtake, in other words, how much forage animals eat. And then you can use that to calculate the amount of time that the animals should be staying in the particular paddock or on the particular area that they're in. So therefore, it's a much more comprehensive measure and descriptor than just using density.
We've had a fantastic conference. We're here at the gala dinner tonight. We gave a couple of awards, one to Professor Emeritus William Bond, who has contributed amazingly to the world of ecology and to the world of science, and he's one of the most cited scientists in the country. We had earlier in the week, of course, running from Tuesday to Thursday, we had the Congress, and we started it out with a focus on climate change and carbon in rangelands and in arid rangelands, and that was one of the greatest sessions I think that we've had in recent years. That followed up with Professor Richard Finn, following on from Professor Guy Midgley, and he talked about essentially how you increase rangeland productivity, how you improve cattle and general agricultural production of rangelands, and that was fantastic. And then today we had a session on fire, and the next Congress, which is going to be our 60th Congress, which is held in will be held in Hilton, Pietermaritzburg. That's going to be next year, and that'll be from the 21st to the 25th of July in Hilton at what was the Hilton Hotel, and it's looking well poised to be a fantastic event.